that you have to work with. So lumping of factors that go into projecting relative sea level rise is reduced to a minimum. So the result is as specific as possible for a community. That makes it locally relevant. If you're sort of lumping factors, and what I mean by lumping will hopefully become clear in the next slide or two, you can really design it for local infrastructure and landscapes. And then also, you do it with the appropriate governance scale in mind. So is it intended for decisions to be made at a city level versus a county level versus state level, for example. And then the other thing, at least based on my experience with these community scale assessments, is that they typically don't have a lot of funding associated with them. What I'm going to present to you today, both of the sort of sea level approaches that I'm going to present, were done within the context of comprehensive vulnerability assessment and adaptation planning processes in which just a very small fraction of the resources were set aside for time to work on the sea level projections. So these aren't research projects. They tend to not have a lot of funding associated with them. As a result, efficiency is paramount, and they often are reliant on other data sets, other resources that are out there. So we can ask, hasn't this been done before? Oftentimes I'm assuming that there are similar products to the two that I'm showing here for a lot of the places in which some of you may live and work. There are two examples that are frequently cited in local planning processes. For example, in Washington State, focused on sea level rise. I show two of them here. Sea level rise in the coastal waters of Washington State, which was published in 2008, and then sea level rise for the coasts of California, Oregon, and Washington, published in 2012. These are sort of regional scale assessments. Both of them are fantastic documents, put together and authored by really outstanding groups of authors